our brains since it's Tuesday. So here's some Math 20 review problems. Which one or two would be interesting to work on together? Are these big enough, by the way?
Let's
20?
29.
29. Okay, 29 is a great one. Oh, go away, menu bar. Okay.
Use your calculator.
You could, but not in Math 20. So we're going to pretend that we have that restriction. So this is long and ugly, and we've talked about terms before in this class, but maybe not very much. Does anyone remember what a term is? No, okay, then I will take you there. So, first, let's do PEMDAS. Okay, raise your hand if you know PEMDAS. Hey, almost everyone knows PEMDAS. PEMDAS is something that they teach in schools pretty early on, and it can be great or it can be terrible, depending on how it is taught. So let's review this real quick, just in case anyone had it taught to them badly or sloppily, and we'll fix things up. So PEMDAS is an acronym. It stands for the order you do things. Parentheses, exponents, multiplication, division, addition, subtraction. And why do we need this? Because when I'm doing 8 divided by 4 times 2, we have two options. Do we say 8 divided by 4 is 2, and then 2 times 2 is 4? Or do we say, oh, look, multiplication comes up higher than division in the list, so let's multiply first. 4 times 2 is 8, and then 8 divided by 8 is 1.
I thought when it came to division and multiplication, we went like from left to right.
Yes, Amanda has it right. This one is good, this one is bad. So, if you were not taught PEMDAS carefully, this could have tricked you. Amanda, to her credit, mostly to her teacher's credit, was taught.
I never learned the PEMDAS part.
So, there's a couple things. One, that we need to remember there's more to life than what it says. In particular, fraction bars happen all the time, especially when you get to Math 60 and algebra and stuff. And fraction bars are just a grouping symbol. Anytime you have fraction bars, you could rewrite it without fraction bars, using enough parentheses. So, fraction bars and parentheses are sort of the same thing. And then, as Amanda just said, multiplication and division are the same priority. If that's all that's left, go left to right. And addition and subtraction are the same priority. If that's all that's left, go left to right. So we really just have 4 steps: parentheses and fraction bars, exponents, multiplication and division, and subtraction. And no one is ever going to write it like this. But in your head, mentally organize it that way. Okay, so a term helps with this. It's an expression that's separated from the equal sign only by addition and subtraction. What do I mean by that? I'm going to say 4 plus 2 in parentheses divided by 3 plus 8 times 2 squared. So let's start over here. Oh, there's a plus, but it's inside parentheses. So that doesn't count. I'm going to keep going. Oh, here's a plus. So this is a break between terms. It's a plus that's not inside parentheses. Keep going here. So those are 2 terms. When I am using my terms, they are separate until the very last step of the addition and subtraction. So these 2 pieces don't care about each other. I could do this one on the left first, I could do this one on the right first, it doesn't matter. let's do each of them. So start here, 4 plus 2, that gives me 6 divided by 3. And here, 2 squared is 4. So 6 divided by 3 is 2. 8 times 4 is 32, and I'm winding up with 34. My brain okay? It's early for me too. So that's the nice part about terms. These little subgroups are much simpler to look at. They're easier to deal with. And we can do each of them separately until the last step when we just go left to right and do all the plus and minus. Okay, if you want, I can keep going doing all of these, but let's, for Math 25, just skip 1 and do 24. Skip 23.
I
Yes.
just wanted to say real quick, if people can't memorize it, and I can't, it's, please excuse my dear Aunt Sally, is what they taught in school, so please excuse my dear Aunt Sally.
That's a good one. Thank you, Edwin. Okay, more complicated one. 9 plus 8 times 2 plus 19 minus 4 by 3. So one part of writing math well is making this not a challenge to find the terms. If you've noticed, I put more space around my plus and minus than I do around my divide and my multiply. So my eye will naturally sort things into terms. So there was 1. What's my next term?
8 times 2.
8 times 2, then there's a plus that's not in parentheses.
19 minus 4 divided by 3.
And there's a minus that's not in parentheses, and then 10 is its own term. So I know sort of the skeleton of this problem, right? I'm going to have 3 things added together, and then I'm going to take away something at the end. So, well, 9 just stays 9. 10 just stays 10. 8 times 2 is 16. 19 minus 4 is 15. And then 15 divided by 3 is 5. So 9 plus 16, we're up to 25. Plus 5, we're up to 30. Take away 10, we're down to 20. Did I make any mistakes? No, we're good. Okay. So now let's do the one that we were given on the practice final. You want to try it yourself before I do it on the board and then have someone come up and do it? Yes, okay.
Can you make that maybe just a little bit bigger?
That one I can't, but I can rewrite
I
it.
just can't tell if it's a plus or divided between the 2 parentheses.
I will rewrite it and then... By the way, you have all been very polite and kind with each other when you come up and see how bad your handwriting is on the board. Everyone has bad handwriting on this board the first time they try it. It is not that my handwriting is especially nice, it's just I have had practice on this particular computer a lot more than you have. I can't fit it all at that pace, but there we go. Okay, try this. When you think you got something right, then come up and do it for us.
54 divided by.
Shouldn't make a decimal. I should fix my randomizer. Keep going.
Alright, so 52 goes into a blunt with a remainder of 2. Right down to 0, so that's a point. And so we go into that 0, so 0, 200, we go into that 3 times. And that would be 156. So that would be 44. 44. That goes into that 0. So round it to that, which is 1. All right. So 12 times 6 plus 1 plus 90 plus 42. Which would be 60, 72. Plus 1 would be 73. Plus 90. So plus 42 equal 5, 11. Yeah, that was pretty horrible handwriting.
That's
But I think that's how we break it up into sections, in terms, and then in order. Anybody
Except
else?
for the rounding, which you could do differently. Did everyone get about that? Oh, okay, let me try it. Thank you. I'm also going to rearrange it so these pages are next to each other. Okay, so I need to write it a little smaller. 60 divided by 5 times 6 plus 54 divided by 52
Oh, I did plus, I think. I think I wrote it wrong.
plus okay, so what are our terms? There's a term, there's a term, there's a term, and there's a term. Okay, so 60 divided by 5 is 12. We still have a times 6. 12 times 6 will be 72. That looks like what you did. This one we were just going to say is about 1, because it shouldn't be a decimal for a Math 20 class. Oops. So pretend that's not a bad random number. Okay, this one. 120 minus 10 times 3. We do the multiplying before the subtraction. And then here, 28 plus 14, so 38 plus 4 more will be 42. And 7 times 6 is 42.
I didn't see the 7, that's where I made a mistake.
Ah, okay. Well, my fault for writing it too long on the screen. Okay, so we have about 73 plus 90 would be 163, plus 6 more would be 169.
I got, what did you get? Oh yeah, I got like 168.
Okay. More homework for me to fix that. Now I am curious, how much does that actually happen? Nine to the fourth. Should be 2 different powers of the same thing. can't break it again. Oh well. My homework, you don't care. Okay. New topic. Topics. So today we get to do mortgages. So as always, I'm not going to read all the cute little comments and things like that. You should be going back either before or after class and looking at these things. But let's talk about mortgages. Okay, our goal today is to find out, based on your household's income, how big a mortgage you can afford. That's an interesting, realistic question. We talked, back up a step, about how the health decisions topics were pretty clear-cut. There were different formulas. You get numbers, you plug them in, you get an answer out. Ta-da. The personal finance decisions were starting to get vague. In typicality, things were vague because we don't know what typical really means in English. Is it most common? Is it most representative? There was some stuff we talked about there. For bell curves, that there were all sorts of problems of how you make your bins and whether the things that you're making histograms of are already averages. And there are all kinds of ways that it can look like it's meaningful when it's not. Mortgages is vague just because household finances are a little vague. Not everyone lives in the same standard of living place of the world. If you're in New York City, that's different than Eugene, and so on. So none of these rules are universally applicable just because no one has exactly the same, kids and finances and other obligations and inheritances, and who knows what's really going on in someone's life. But as a rule of thumb, for the hypothetical average person, then these are good guidelines. It's also a little more difficult because there are not formulas. There's just a process to follow with lots of steps. And I try and be very careful and lay out all the steps smoothly and clearly. But there's an awful lot of them. Buying a house is complicated. So there's just a lot of little ways to make mistakes. A lot of opportunities to hit the wrong button on your calculator and so on. So here we go. The general rule is look at last year's taxes, find 35% of your before-tax income, and find 25% of your after-tax income. Somewhere between those numbers would be what you should spend on housing. Again, maybe not in New York City, but we're talking about the average place of the world. So that would be your annual housing cost. Divide it by 12 to find what your monthly mortgage payment would be, or rent if you're paying rent. So the Wall family gets out their taxes and looks at things. Their pre-tax income was $60,000. Their after-tax income was $52,000. So multiply by 0.35 for the 35%, or multiply by the 0.25 for the 25%. Divide by 12, and there we go. They should be spending between $1,083 and $1,750 for a mortgage payment. Everyone okay with that? I haven't actually gone around checking with my friends and family to see if anyone in Eugene follows this advice or not. So I don't know if this is good local advice, but so they think about their priorities, because that's a pretty significant range, and decide to err on the side of caution. Let's spend about $1,100. Okay, so they know what they can afford. How big a house do they get for $1,100 a month? So this is a really complicated math problem. Over time, they're going to be paying off the loan. It'll get smaller. But also over time, the interest will happen, and the loan will get bigger. So it's sort of like two different forces in two different directions. And you can make a long table and figure it out, and use some guess and check and so on, but it's just a big pain in the neck. So fortunately, someone has solved this already. The name for this process of I'm going to pay the same repeat making scheduled payment. Most people don't pay the same amount on their credit card every month like they do a mortgage. But for something like a mortgage where you pay the same amount month after month after month, that's called an amortization. And this is the amortization table. It tells you if you were to have a $1,000 loan, notice the little blue 1,000 up here at the title, then how much would you have to pay each month to pay off that loan for a certain number of years? And unfortunately, this table is out of date, but it's the official Math 25 table, so I'm not changing it. We have good news. Mortgage rates really can be below 5% and have been for a while. So, worst comes to worst, you'll be more afraid of expensive mortgages than you should be after this class. But yes, the 8% type problems are a little unrealistic right now, happily. So, if I had a 20-year mortgage at 6%, I would pay $7.16 each month. And at the end of the 20 years, everything would be balanced perfectly, and I'd pay off my last payment, and so on. Yes?
Is that the interest paid or the loan paid?
That's my monthly payment.
Including interest.
The interest gets paid off during that time.
Thank you.
So, that's a nice table, but you can't buy a house for $1,000. This is, go to Jerry's and get a garden shed with a mortgage kind of thing. So, what do we do if it's bigger? If I go to the bank and I get a $100,000 loan, then what would I do to these numbers? Multiply them by 1,000, right? If I have a $200,000 house, I multiply them by 200. Whatever is the number of thousands, that's what I multiply by. Everyone okay so far? Okay, this is not what we want. We want the other direction. No one is going to get a mortgage and then have the mortgage broker say, by the way, your job as a homeowner is to find an amortization table and tell me your monthly payment. No, they just give you the number. So this isn't what we're looking for. We're looking for the other direction. So we have to use the table in a funny way. Okay, let's use it forward just to go slow and carefully. What's the monthly payment for a $130,000 mortgage with a 20-year loan with a 6% interest rate? So, what number do I peel off the mortgage size?
6%.
That's
On the chart.
on the chart. We need the 20 years and 6%. So we go back
716.
and we say 20 years, 6% is $7.16. Okay, what other thing do I do?
What's the 716?
That was, whoops, wrong way. 20 years, 6%, that's where they cross. What do I do with that? Yeah, I'm going to take this 130, peel off the 1,000, and what's 130 times my $7.16? 930. Rounding.
I think for 130, you still got to go to Jerry's. Yeah. Yeah.
Everyone okay with where the pink number came from compared to where the green numbers came from? And then we put things together.
For the 716, is there like it's just $7.16 per month, or is it just
What we're doing, imagine a story. I have this briefcase. Use your backpack. I come into the bank with this briefcase full of money like a mobster, and you're the bank teller. And I say, here's $7.16. And you say, great, here's a $1,000 mortgage. And I say, here's another $7.16. And you say, great, here's another 1,000. And I keep doing this. And after 130 times, I run out of money in my briefcase. So how much did I get for my mortgage? 130,000. Okay, ready to go on? Okay, so that's again not what we want. We want to do the opposite. They can afford 1,100 per month. So they want a 30-year loan and 6%. How big a loan can they afford? Let's do that. Well, clearly we want something in green again from the table. And the table says for 30 years and 6%, it's $6. Oh, okay.
Does this turn into a ratio problem or an algebra problem?
It's just arithmetic. Think about what we did with yield percent and other scale factors that we have to use backwards. We've seen this before more than once. To work forwards, we did some multiplying. So we have to divide. Okay, so whoops, there's a typo there. That's too many zeros. Get out of there. Okay. We're finding so many typos. Okay, so we take that and divide it by the $6. And whatever we get. Okay, so this is the red number in front of the 1,000 on the mortgage size. Does that make sense? So we have two options here, and there's not a right and wrong math answer. We could say most mortgages we talk about in thousands anyway. I'll just round it that way. Or we could say, no, I don't want to keep all of my accuracy. So I'll keep all those threes. In this class, we're going to do the first one, just to be simple. Whatever number you get, round it. In this case, rounds down, and then put some zeros after it. And that's just so when you work together or pick things on the grading page of the homework once they get it ready, then we'll all have the same thing. But there's nothing wrong with the all pink number. If you wanted to shop for a slightly bigger house, then this is less of a difference than how much you're estimating your finances anyway, right? So. Okay, so where were we? So that one was 930, and this one is about 183. In this box, I'm walking through the briefcase of money thing that I just did a moment ago. They show up with $1,100 in the briefcase. They give $6 to the bank teller. How many times do they do that? They run out after 183 times, so they got 183,000. Okay. So, it seems like we're done. If shopping for a house was as easy as shopping for most things, then yeah, let's look for a $183,000 house. Problem is done. Everyone know about Zillow? Yeah, so Zillow, somebody give me their neighbor's address so I don't have to reveal your own address.
2492. West Irving Way,
Eugene?
Oregon 97402. I'm just guessing on the last two.
So Eugene or Springfield?
Eugene.
Why isn't it?
I can do my own.
Okay, sure. What's yours?
1800 West 25th Street.
And again, there it is. That one it knows. Okay. So, where's the prices? It normally gives you prices of everyone nearby somewhere. I admit I haven't used Zillow in a while. There it goes. So you can see, scale out all the different price values around for this neighborhood. And if you click on more, you'll see when they last sold and all kinds of good data. Okay, that's Zillow. We don't really care about Zillow. Back to math. Okay, when you actually buy a house, then here are the things that are more complicated than just buying a TV or something. One, you need a down payment. And before, we were sort of imagining that the 183 was all loan. But no, the loan, the mortgage only is how much doesn't have the down payment. Because the down payment, you're not borrowing, you're paying. Most mortgages have a fee, 1 to 3%, and people might get upset if they're realizing they're paying 3%, so they use the word points instead. You have 3 points on this mortgage. Mortgages often require paying one or more monthly payments up front. You have all the inspections and other things to do for the house. And there's all these little fees that happen, and so on. So we're not going to go into detail about that since this is a math class and not a buying a house class, but we'll pay attention to them in a sort of token way. So let's continue with the Wall family. They wanted to spend $1,100 a month. They got $183,000 as their ballpark size for what to shop for. So they find a house. The down payment is 20%. So what's the actual mortgage amount? We have to take away 20%. So you could do this in one step just by saying how much is 80%, or you could do it in 2 steps by finding the 20% and subtracting it away. Which one should we do on the board? 20%. Okay, so we're doing this one. So 20%, so 0.2 times the 183,000. So 183 times 0.2. 100. So 146. 400. Hopefully that's what my thing says. Yes. Okay. So the loan is 30 years with a 6% rate. So that was the $6, right? We've done that already. Did I make it 0.4 here? 0.6? Yes, I did. So then we're going to take the $6 and we're going to multiply it by, now you could just do 147 round, or 146 rounding this one. I should make it 6. But I'm actually going to do the 6.4. Did I do something wrong? Nope, I just had a typo in my other one. Oh, okay, well, I'll have to fix that too. 146. 6.4. Okay, so for most of the 30 years, they're going to be spending less than they budgeted, less than their 1,100. But they also took a big hit where they had to get 36,600 up front. So that's how it goes. Okay, the mortgage has a 3% fee. Let's think about that. So 3% fee, so 0.03 times the 146,400. So that's 4,392, which is how the mortgage broker makes a living. And the first month's mortgage, well, that's this amount. And the inspections and other things are 200 and 900. And then you add up all these numbers. How much do they have to have for all their upfront costs? Well, I'll use blue for this one. So the down payment was the 36,600. And the 3% fee, and the first month's mortgage payment, and the inspections, and the other stuff. Did I miss anything? I think that's all. So what did we get? 36,600. 42,970 and change. Oh, come on. That's a lot of steps. As I warned you at the beginning, none of this is really that hard. There's just a lot of opportunities to make a careless error. And everyone makes careless errors now and then.
Some does show about 24% of what they need of the value of the home to buy it.
Okay. Questions about any of that before I take it off the
I have
board?
a quick question.
Sure.
So when we go, how come we turned the 146 or 146,400 into
Excellent question.
146?
I'll pick a new color. So the $6 is per thousand. So I have to do 3 decimal scoops to change this number from counting in ones to counting in thousands. So I do my 3 scoops to whatever the number is for the mortgage size. Make this look like a better 3 scoops.
So if that was like 1,146,400, would you still apply the same use of the decimal point?
Yes, I would still move it. And that would be an expensive monthly payment on a mansion. Okay, I'm just going to give up on writing that S immediately. Okay. Okay, yay. So hopefully you can repeat all those steps, and when I see you on Thursday, we'll do another example of this. We'll just make up another family, go through exactly the same steps, and see how things are. Okay, from the point of view of the bank, the story is just starting. Mortgages are a big deal to homeowners, but mortgages are also a big deal for banks. So let's look at the bank side of the story. How much will the Wall family pay over 30 years? That one's easy. I'm just gonna. So, unless I had my thing wrong. Nope, $878.40. Okay. So every month they're paying $878.40. There's 12 months per year, and it was a 30-year mortgage. So do the multiplying, and there we go. So for a house that was 146,000, they're paying $314 total. So almost double.
It's 183. The 140 was after a down payment.
Oh. So that's a lot of interest. On the other hand, it's better than being homeless. So there we go. This is why that you get a tax break for your mortgage payment, so that this doesn't sting as much. How much was interest? Well, I'm estimating badly here, so don't look at this, but put the 4 in there. Right? I'll just do it right, actually. So this was a 4. Whoops, make it. So that means that that's going to be a 3. So 168,384 of the mortgage is interest. Actually, that's more, so they more than doubled it. Doing my mental math bad. Okay, we can subtract, not a big deal. So, is the bank greedy because it charged them so much interest over 30 years? No, actually, it's afraid. Let's talk about this a little more. If the bank instead invested $183,000 in the stock market, how much would it expect to have after 30 years? We'll learn how to do this in the next section about saving for retirement. But for now, just trust me that the answer is about $2.5 million. So why would the bank get 100 and whatever it was, 60-ish thousand of interest when it could get $2 million on the stock market? And the answer is that the stock market jumps up and down. Here's a picture of how it behaved from 1950 until the 1997 recession. Sometimes it's above its average, sometimes it's below. Overall, it increases. So if the people that are loaning money to the bank wanted their money out when it was below its average, the bank would be losing money. If the people that were loaning money to the bank only made withdrawals when it was above average, that would be great for the bank. But the bank doesn't get to pick. So because the bank can't pick, and it's worried that people will need their money when it's below average, which during recessions is when people tend to need money anyway, then yeah, the bank can't play that game. So that's why we do mortgages with banks, because we as homeowners are boring and reliable. And they know that we'll just pay our little bit every month, and the bank is only getting a fraction of its potential income that an investor would get, but is sure of what it will get. Okay, you've heard of the Great Depression. The Great Depression was when this didn't work. The banks were investing in the stock market, and the regulations that prohibit this weren't around. The banks didn't just cause the Great Depression. Remember that interlude from Factfulness about don't blaming villains when it's usually systems. What happened? During the 1920s, consumer debt doubled. Borrowing money was too easy. We could buy household appliances and automobiles and all these cool newfangled things. And everyone realized they couldn't borrow and spend anymore. And so the demand for more goods and construction plummeted. People weren't buying more cars or houses or things like that. And when the demand for all those new things plummeted, then you couldn't pay people to go to work to make those things because no one would buy them. So the businesses were stuck. They couldn't keep expanding. There was nowhere to invest their money. And so they hoarded their wealth, which is a little bit of a problem today if you know like how much cash Apple is sitting on or Alphabet is sitting on or things like that. So what do we do? If you're hoarding your money, in one sense it's safe. You're not going to lose it when the stock market does badly. But on the other hand, it's not moving around. There's this concept of the velocity of money. If I take $1 and I spend it at the grocery store, she works at the grocery store, she goes and spends it at the movie theater, she works at the movie theater, she goes and whatever, do something and so on. The money moves around. Each dollar that's out there gets used more than once, unless everyone is just hoarding it. So the money supply dropped by about a third. Not that there was less bills out there, but people weren't moving it around as much because we had shopped all we could shop in the 20s. So that was like a traffic jam. There are things that needed to happen with money. There wasn't enough money. It got kind of squished. And the 2000 recession was similar, except instead of cars and TVs, it was too easy to get mortgages. And so everyone had spent too much on mortgages. And again, the same things happened where the velocity of money had problems and like that. And why that happened was because of a math formula. There was a famous economist named David Lee, and he invented a formula to measure how you could combine certain kinds of risks together. that if you were offering insurance and there was this risk you were insuring against and that risk, then what was the overall risk? And that would be great. Businesses have to know about risks, and if there was a formula that would let them combine their risks into one number, that was great. So they treated this formula as it wasn't supposed to be used it for other kinds of risks and other kinds of scenarios. And once the mortgage lenders joined in and treated mortgages that wouldn't get paid back as a risk you could bundle in this formula, which they weren't meant to be, then this was going to happen again. So there we go. In a certain way, a math formula caused the recent recession. More stuff. Read that at home. It's just interesting. Calculators. We'll do that if we need to. If you go there, then the calculator talks about when numbers are too big to fit in your calculator screen, what to do. The previous answer key, if you haven't started using that. The exponent key, the pi key, and why you can't use the percent sentence, the percent key, because it does different things for different problems. And the square root key. So we'll talk about those more as we use them for real problems. I'm not going to do that in class. Okay, so that's all of mortgages. We have about 9 minutes. So don't run away. Talk to the people. Maybe they'll be brave and raise their hands who haven't turned in the first 2 homework assignments yet, and get those done. I want everyone to at least have 2 done. People are close. And we'll do more mortgage on Thursday. I would rather not rush ahead to saving for retirement, because this was a lot of steps. We need to do more example problems.
Do you know the conversion kit for metric and what do we call it, standard?
Okay, make noise, talk to each other, ask each other about homework problems, whatever you need to get the patterns and the calories done. I'm going to stop.